John's talk is in the big room where you had the keynote. If you run, you can still make the good bits.
I don't need to introduce him. Hell, you were all here for the beginning. Rusty Russell, welcome.
Thank you. Okay. Okay, who's been to one of my talks before? I knew I should have put something new in there. Okay. Right. This is my talk, Advanced C Coding for Fun. It's about C coding, so there will be C code. If you are not a C coder, exits that way and that way. That one is the best. Go straight across, straight back into the keynote venue. Happiness ensues as you watch John Corbett's talk. You will actually be watching C code. It is advanced. If you do not know C, this is not the time to learn it. It probably will scar you for life if this is your starting point. It's certainly not for profit. That's why that's there. And this is me. Now, unfortunately, my slides go about 10 minutes too long, so I'm not actually going to do it like this at all. We're going to do it like this. Okay. So, yeah, no, that's not a good thing. I was going to cut a few things out and polish it a little bit more, but for some reason I felt inspired to write a CCAN module that allowed you to simultaneously connect over IPv4 and IPv6 last night. And so, yeah. So this will be a little bit less polished. What we're going to do today is we're going to write a server called OServer, and I'm actually going to write it as a CCAN module. The reason I'm doing that is that most of my tips and tricks have gone into other CCAN modules, so I get to wave at them as we go past. This is going to be very, very quick, and there's going to be lots of hooks in there, like URLs on the side and stuff, and I expect you to all be furiously typing away and missing what I say next. Okay, so.
Rusty, you have a cell phone in your car?
Yeah, I do.
They interfere with the wireless mic.
How annoying. Okay, let's also switch to silent mode. Okay. Right, so we go to that. Okay, so this is what our server looks like to start with. It has two functions. It has a setup function and a serve function. I'm not going to spend too much time on the mechanics of the server itself, except to know that it exists and it's fairly normal C code. The first thing you'll notice is actually I've already pulled in another CCAN module in order to get the GCC wrapper for the no return stuff. It does exactly what you'd expect using the attributes, GCC attributes in a nice portable way. And here's what it does. Setup basically sets up a socket, binds and listens. Anyone notice that that's using IPv4? Yeah. I didn't have time to rewrite it between the keynote yesterday and today, so still using IPv4. It returns the listening socket waiting for connections. Once you connect, you call OServer serve, which basically reads in a string until it hits a new line. Uppercases the whole thing and just writes out, some stupid string with the whole thing uppercase. Okay. Another CCAN module there, write all, very simple write loop that just repeats the write until you've written the whole thing out. Really, really dumb. Okay, this is an incredibly simple server. Now, by itself, this could actually be submitted to CCAN today. Because we accept anything in the whole true to junk code style. There's a whole junk code section, and I just take anything that is C code or resembles C code, and I put it in there. But if you really want to be, what the hell? If you really want to be a CCAN module, then you should have some other things. And if we run ccanlint, it immediately complains that we don't have an underscore info file. Shall I create one? Yes, create one for me. Your info file looks like this. It's a little C program. And you type a little bit and you populate it like so. Okay. Very, very straightforward. Okay. There we go. It's a little thing. It has an example in it. When you execute it, it gives you the dependencies, dependency information, in this case, the two other modules. Okay, cool. So run ccanlint again. Okay. Now, it complains about not having any tests. It actually gives a very, very long, verbose complaint that I don't think I can fit on the screen about how you should write all about testing. I mean, one of ccanlint's thing is take my code and turn it into a ccanlint module and just keep ccan module, just run it again and again and again until it stops whining at you. It even offers to create a template file for you. You create a run test. You notice that it doesn't get linked. It actually has to include the C file directly. We use the TAP module, which is based on the Perl Test Anything protocol. It's very, very simplistic testing. Some would say overly simplistic, but if we're talking about C coders, getting them to test anything at all is an achievement. So you basically say how many tests you're going to have, and then you do some tests. So we type, and away we go. Okay, now in my test, I'm going to cheat. I create a temporary file. The test will get run in a temporary directory, so you can just drop turds everywhere. I open a file called runfd. I write the input to it, seek back to the beginning, and then I run that oserverserve function in a child. Then I wait for the child to exit, because oserverserve will actually exit. Check it exited OK, and check that it appended the string we expected to the end. OK, all good. Now this will make ccanlint happy. Ccanlint, and it no longer complains. OK, good. But our score is still pretty low. If we run it with verbose, it will tell us about the things that we passed but didn't get 100% in. And I'm first going to concentrate on the fact that it complains there are no examples in oserver.h. In fact, there's no documentation at all in oserver.h. So we should write some documentation. It looks like this. Told you we were going to have to go fast. Keep up, people. Okay, right. I'm not a fan of this document extracting phase. The documentation should stay with the code, but it should have some vague structure in that you can actually do some sane parsing on it to check it. In this case, you can see this example here, and the example for serve, and we've inverted the two, so we've put, as you expect, setup at the top, because I believe your header should be readable. And we've actually put these dots here. You see that this second example won't compile by itself. ccanlint's smart enough to figure that it has to sew them together to get them to compile. OK, ccanlint-v. It will now no longer complain about no examples. The thing that it's complaining about is our coverage. We're getting a 0 for our coverage test. Because ccanlint uses the heuristic that if you get 50% coverage, you get 1 point. 75%, you get 2 points, etc., up to 5 points, and you get a bonus point if you hit 100%. We don't even get to 50%. That would probably be the function that we don't test at all. Let's look back at our testing and see what we can do. Okay. Well, the first thing we could do is actually test more than one string. The standard way to do this in C, old school, would be like this. You would declare an array of all the things you want to test, and you iterate through the array. You would use the array size macro, which basically takes the size of the array, divides it by the size of a single element. This one has a few twists in that you hand it that something's not an array under GCC. It will spit out this rather bizarre warning, but you will get a warning. So when you refactor things from an array to a pointer, at least you'll find out the places you've got array size rather than randomly getting 1. Very, very important. The other thing you may have noted that I actually had an example before is this. I've been coding in C professionally a good 10 years when I made that mistake again and got strcmp around the wrong way. And so since then I've decided I'm going to write a wrapper and use it everywhere. Of course, I've never made the mistake since either, but a vast majority of the time you want to use something like that. That is in the ccan strp module, I might add. Okay, so that's all good, but it kind of sucks. I mean, basically anyone who's writing used to scripting languages goes, this whole array, so you can iterate through, is a little primitive, and they're right. There's a ccan module for that called for each. For each pointer, in fact, will iterate as you expect, iterate input through those various constants. So input will first be set to that around the loop, and then that one and that one, exactly what you would expect a for each loop to do. There's a BOF on this macro, on this ccan package that's tomorrow morning. Because I don't have time to cover it here, I do not recommend you look at the code without holding someone's hand. It's a little bit like that. I'm very, very proud of it. Actually, that's the wrong URL. Sorry, it's actually that one. Did anyone get rickrolled? Too quick. Okay. Blah, blah, blah. Where are we? Okay. So that's for each, but of course we still haven't actually improved our coverage very much because ccanlint will still tell us that we score 0 for our test coverage. Okay. If we look at what it's actually doing, we run it with double V, and we will see that server.c, it will actually print out the the gcov output and it's not testing the read failure case here, where we exit. There are ways of actually testing that, the classic being to override ERX with something that does a long jump back to the original code, and I've done that before when you really can't modify the code. That's why we use the hash include rather than linking against the module, so you can do ugly macro tricks like that. But really, the better thing to do in this case is to change this function to actually return a bool and just return false when it fails, and leave it exiting up to the external. Now, we've changed our function a little bit in order to make it easy to test. I feel that people who do not consider testing when they write their code are a bit like people who build a building and go, I'm not moving anything to put in loading bays and maintenance corridors. It's going to be really messy, and at some point someone will point at the messiness and go, you know, those lifeboats make the whole thing look cluttered and you'll end up in problems. Okay, so, you know, it's definitely worth making minor and sometimes not so minor changes to make it maintainable, assuming that you are actually ever going to have to maintain it. There was a joke in there about the necessity of having Jeffrey's tubes, but I left that one on the floor for lack of time. Okay, so at this point you're going, wow, he's going on about testing a lot, but we will get through this. Now, if we're going to do that one, we might as well do O-server setup, even though for lack of time we don't actually test it. What's interesting here is that instead of exiting, we now just return is this function. If we fail to bind, we have to close the socket before we return -1. As all of you should know, libc is quite happy to destroy erno even when there's no error. So you have to protect it. And there's a ccan module which provides you with a whole heap of wrappers that just do that for you, because it's such a common thing to want to do. So we do have to fix that up. Other than that, we're pretty good. Our coverage, of course, we haven't actually changed anything, so it doesn't help. So the next thing to do is to go and add another ccan module. It's a bit of a silly example for this, but this is the fail test module. Was anyone at OLS the year that Jeremy and I gave our talk on NFSim? I was there. Oh, okay, you were there. Yeah. Same trick, basically, new clothing. This fail test override before you include the main C file basically macro overrides malloc, open, pipe, read write. We've only got a few so far. And every time you call that, it basically forks off the child and the child will fail. And all you have to modify your program is you call fail test init at the beginning, and then instead of exit, you call fail test exit to clean up. That's it. And that will do basically add fail test testing to your program for free. Now, there is one other thing that I did, and that is I used the tap fail callback, because normally tap will quite happily fail one test and keep going. That leads you to combinatorial explosion. So there's a callback you can set in tap, at least as of 2 weeks ago, which in this case I just make it exit immediately as soon as we fail. That way we don't get our children exploding as well. Okay, so now if we run this, we look at our coverage, we'll see that it takes a little bit longer. We look back at our coverage, we can see we've actually covered that read failure case here. In fact, we covered it 90 times. So you didn't even have to write any new tests or anything else, you just added fail test and boom, you got your testing. There's a whole heap of hooks you can put into fail test, and we're working on making ways to make it extensible and everything else. Because if you notice, we didn't test the write all fail case, because write all isn't overridden by fail test. So fail test is awesome. If you're pretending to write a program that can handle malloc failures, and you're not using something like fail test to actually check that you are, you're not. And frankly, in a lot of cases, you're so much better off just giving up. Because I mean, every time you will find bugs. Coming soon, yeah. I'm still thinking about it, but you know, I had to talk to Wright. Okay, so now let's get back to some actual functionality adding, because it's so much more interesting than testing. Let's add some options. Who here has used getopt? If you haven't put your hand up, you shouldn't have been in the room. Okay, who here has used popt? The Samba one that up here. Yeah, pop's not bad. It's like popt, only I think it's what I wanted popt to be. I actually had some interesting discussions with someone who's looking at rewriting popt, and eventually this discussion stalled because he didn't have time, and I eventually thought I'll write him a little example version of how I'd like the interface to look, and next thing you know I had another CCAN module called opt. I did send him a link. If you want to call that popt2, go nuts. It is different from popt in that it's extensible and it's type safe. Type safe is good. You can register tables of options the same way you can in popt and get opt long, but you can also just chuck them in at runtime. And for an example like this, that's the way you do it. Two options here: help or usage or -h, which just prints up. It uses a standard opt helper, opt usage and exit, which generates the usage table and all that stuff. And we have a port option. And we use another built-in opt set uintval, and in fact opt show uintval. I can actually run this. Now, what's interesting here is, and I want to divert a bit into the usage of opt, is that we use the type-safe callback module, which avoids the whole classic void star thing. You're handing your callback some random pointer, you change the type, and the compiler still treats it as a void star, so it has no idea that it should give you a warning about that having changed. Type-safe callback actually checks that this function here takes the same thing as this thing is here. So if I actually change that unsigned int port to something else, I will get a compiler warning. A really odd compiler warning, but I'll get a warning. So, sorry? Look in type-safe callback. A heap of GCC extensions.
No, I mean as far as usage.
That has to have the right type to match that. Just believe me, it works. This is in fact a macro that does the macro magic around the real one. Yeah, look in the mod. There are lots of examples in there. Okay, so type-safe callbacks are really important. Now, because it actually builds that example, we can actually run it. And there you go. It prints out help, as you'd expect. Okay. Now, a little bit of divergence here. Oh yeah, then we call opt parse to actually do the parsing, and then it basically leaves any arguments left in argv that weren't options, and so in this case we just go blah if it's wrong. So very, very straightforward change. Two things to note. One is that it's much more grep friendly. Rather than grepping for port to find out where someone's put the stuff that sets the port, you can actually grep for -- port, and you will find the place they've registered the option. And I'm going to divert a little bit, and this is the only diversion I can afford to do, is to the header here. When you build up an opt table, you do the standard thing in C where you build up a table and the last one is a row of nulls, so it knows a table at the end. We don't do that. Our opt-end table is in fact not all zeros. It's in fact opt-end, which is 8. 0 is in fact not a valid type value for that field, which is the type field. The reason for that is that one of the most common sources of bugs is that you forget to terminate your table. And it works beautifully because the next thing in memory happens to look all 0-ish. And it works fine for you until something else unrelated changes. So don't do that. It makes it slightly easier to use to have that, but it makes it much easier to misuse. So hard to misuse should always be the aim of library design, and so opt-end is not 0. Okay, so this, however, is still not a real server. It is actually kind of pathetic. If we have a real server, it will need to do something radical like have multiple connections at once. People have these expectations, and there are two ways when we think about how do we handle multiple things to do this. You basically have some kind of select loop thing, or you use threads. Those who know me knew that that was never going to happen, so I did briefly consider turning this into an anti-thread tutorial and spending the time that I actually spent writing this code on actually turning anti-thread into something that I wasn't embarrassed to show to people. But in the end, it was just simpler to go, no, let's go for an event loop style thing. I chose to use T-Event. There are a whole heap of libraries out there. T-Event is a little bit baroque these days, but it's what Samba uses. And it's a very straightforward, here's my file descriptor, here's my callback, throw all those in and then call the event loop and it will call all the callbacks. Very, very standard stuff for this kind of programming. Of course, at this point, we're basically talking about a complete rewrite of OServer, which would look like this. And when we look through it, We have a structure for each client, because now we have more than one. It has some state. First it's receiving a user question, then it's sending an answer, and then it's finished. For each state, we have whether we're interested in reading or writing events. We have our event struct that we've registered, the file descriptor itself. We have the question that we're reading or that we're sending out. We have the number of bytes sent. We have an array of 5 clients. We have the listening file descriptor and the event struct for that. Yeah, well, you know. So our setup function, basically, our interface has changed radically. We now just have a setup function because it registers all the callbacks. Now, T-Event uses talloc. Is anyone not familiar with talloc? Okay, you're in the wrong room again, but we will go through that very, very quickly. So we do our socket and everything and listen, but then we basically throw it into the event context that they've handed us, with the callback being add client. We set it to auto close as well. So when they get a connection, we call add client. We set up our client state. We do a accept. We register that file descriptor with our event context, and we say service client when that's ready. We go through our clients array. We find something. We go, oh, okay, here's my slot. We set our pointer up so our client's in the array. We set up destructor. So talloc is a hierarchical allocator. So every time you allocate something in talloc, you can then allocate other things off it. And when you free the parent, you'll free the rest of it. It makes a lot of memory handling much, much simpler and much nicer. One of the things that it does also give you is the ability to go, when you free up this memory, here's the destructor, so things can clean themselves up, which turns out to be incredibly useful. So that's what the destructor's about. And as you'd expect, cleanup client just goes through the array, finds itself, nulls itself out. The other twist is that if our array is full, we actually tell T-Event we're not interested in any more any more things on the socket that we're listening on, so it sets that event flag to 0. So in the destructor, when we zero ourselves out, we have to say, okay, we're interested in read events again, so new connections can come in, just in case we were the one that made it full. Okay, our state machine looks like this. We read a string. If something goes wrong, we go fail. If the input's finished, we uppercase the whole thing, set our state to sending answer. Sending answer calls send string, which does exactly what you expect. If it's finished, it bumps the state by 1. We should never get to a default state in here. If we're not finished, we return. Otherwise, we talloc free. We just free up the client, which will call the destructor and have it remove itself. Okay, cool. So that is our simple program. And that is what the talloc hierarchy looks like. We have this struct T-Event FD thing that we register, and we hang the client off it, and off that we hang its thing, etc., etc. Okay. Now, there are 2 things that suck. Oh. No. That threw me. There are 2 things that suck about this library. One is the use of void star. This is not an appropriate usage for void star. This should be a struct oserver, right? Because you can quite happily in C have declarations without definitions. So they don't need to know anything about it, just that it exists. That makes the library user's life much, much simpler because it's a lot harder for them to misuse it. And the other thing, which happens to involve the same solution, is this global here. We should put that inside a struct oserver. We'll obviously need a back pointer from our client to say which oserver you belong to. Even if you have no intention of anyone actually ever creating multiple oservers in the same process, there's nothing particularly to stop them, so you should make it more robust. And while we're doing this oserver trick, we should. Our talloc hierarchy will now look like this. We have the struct oserver. That contains everything else. And we told them in the header that they could simply talloc free the thing that's returned, and it would all get freed. And in fact, that will happen correctly. When we free up the oserver, it will destroy that, it'll destroy that, it'll destroy all the clients that hang off it, it'll all clean up. They will call their destructors, all good. Okay. Yes. So, having done that conversion, we run seqanlint. Okay. Die. There we go. Okay. Valgrind. I cannot say enough good things about Valgrind. Of course, CKNLint runs your tests under Valgrind. I actually heard a story of a busload of orphans that were heading towards a cliff who installed Valgrind. You know, it's amazing. I don't understand their logo, but it's amazing stuff. So it tells us that in oserver.c, we can actually have it attached to the debugger, but if we just go to 172, it becomes pretty obvious. When we move this client's array into oserver, it used to be a static, so it's implicit, you know, it was defined to be initialized to nulls. We didn't explicitly initialize it when I moved it into the oserver struct. So when we allocate the oserver, I just tell it and didn't initialize it. That's what Valgrind's complaining about. So we fixed that up. We are at a clear clients, which is a bit gratuitous and marginally non-portable. And we call it from oserver. And now Valgrind should be happy. Let's run CKNLint again. And this time it will be happy. Okay. So, we're still pretty pathetic. We basically receive an answer and spit it back out in uppercase. We should at least get back to where we were, where we send a greeting. So we add a few states. When we send a greeting, it looks like, welcome, please ask your question. And then it says our answer is, and of course then spits out the same string in uppercase. Okay, that's still pretty pathetic. Slightly better is to actually change it just a little bit and keep the last answer that they gave. So the last question that they gave, and use that as the answer. So we change it slightly, we ask you a question, and then you say, I believe a better question is, which is a great political stunt. Okay, if we do, actually, I have a script that does this for me. It's called run server, which I think should work. Okay, it doesn't work. I wrote that in the keynote this morning, so no huge surprise. Dash v dash k wall. So CKNLint creates a temporary directory and then blows it away afterwards, unless you say just keep. You can tell it to run a particular test too, but I can't remember the syntax off the top of my head. So 26 example _ info oserver. So then we go telnet localhost 2727, and we go how much would a woodchuck chuck? And it says, you know, that it had a pre-canned question. So we tell it again, if a woodchuck would. Do you know how long it took me to come up with that? So, you know, it basically just gives you the previous question. Okay, so that's dumb. Now, my plan was to basically leave that running so that you guys could tell it in, but because the wireless tends to go up and down and I wanted a fixed IP address, I plugged myself in. The downside of that being you guys can't reach me anyway. So, but, you know, let's pretend that you guys are all furiously trying to crash my flawless server, which could never be crashed. And that I'm equally relieved that I'll never have to put that statement to the test. So there's a local bin parrot, and let's run parrot. Okay, so there's our server off and running. Cool, so if any of you managed to get onto my IP address there, then you would be able to tell it in and ask yourself stupid questions. Okay, now let's turn this into a real, a bit of a real project by adding a few more states. In this case, I will give you, what did that actually say? Okay, cool. I'll actually give you a demo by doing rm-rf temp. Blow away all the CKNLint stuff that I've had temporary before, and do CKNLint-v-kl temp CKNLint tab example dash _ info. So basically, I'm just using the info. That example that was in the info, that is my server, which is a little bit odd. But okay, so now for this, I would normally use someone else from the audience, but I'll do it myself. We've changed the port number since we've changed the implementation. I've left the other one running to 2828. Please ask your question. Since this is supposed to be an oracle, we'll say now we can ask it other questions like this one. And of course, it uses the old trick where it goes, oh, well, while I'm wondering about that, why don't you answer, here's another question for you, and you say something like, I don't know. And this one says, I don't know. What's open Solaris? Okay, and sorry, no. For those of you who remember the early 90s, this is, of course, the Usenet Oracle. For those of you who don't, it's like chat roulette without the nudity. So, okay. So, the state machine now looks like this. I'm not going to run it in too much detail, but we've basically just added a few states. Particularly, we end up, this is an example, we've got 2 clients set up, and at some point in the state machine, they look to find, you go, oh, I'm trying to find my Oracle, which is another client, and I'm going to be someone else's Oracle. So we have a sub-client pointer and an Oracle pointer. So sometime in the state machine, as we get to you need, when it's going to ask you the question, it waits till it can find one. If necessary, it jumps into that state that says wait for client. So someone else looks through, oh, you're in wait for client. Okay, I'm ready, so let's swap. So that's a pretty straightforward code transformation. Let's see, we've enhanced our state machine now. It's getting a little bit more serious, but it's still kind of dumb. Now, so when our input's finished, we go get a sub-client. If we've got one, then we move on. Otherwise, we go into the waiting state. And similarly, we look for an Oracle for ourselves. And then when we've answered the question, we bump the other person out of the state. All very, very simple stuff. There's just one problem, and that is that what if a client disconnects? You go, well, while I'm doing that, ponder this question, and they just leave. Well, I didn't quite know the answer, so I wrote a test, which looked like this. And of course, it just starts a client, which then forks off a client, which then disconnects halfway through. And in fact, it starts 2 clients, in this case, tells one of them to disconnect halfway through, and we see what happens. Oh, ccanlint. We're on ccanlint. And of course, it goes away and runs all the tests, and of course, hits Valgrind, and Valgrind goes use after free. Okay, I'm not going to go into the details of how you should actually fix that. I had a real moral here about just because you fixed your test doesn't mean your code doesn't suck. The way I do it is that every time in the client destructor, I now go, oh, I was someone's Oracle. Let's just set that pointer back to null. And then every time they need an Oracle or they're about to do something, they go, do I have one? Or let's just find another one if we don't have one. That means you get reconnected randomly with someone else. So if you were halfway through answering someone's question and they vanish, your answer will go to someone else. The true believers would consider this a sign of the mysticism of the Oracle. I consider it a feature and refuse to fix it. So, okay. So we hack that. All good. Where did I actually hit that? Test just doing answer. Okay, cool. So I fixed that. Hack, and we basically just reconnect as required on demand. It almost works. Now, a serious problem with this kind of server is Valgrind's great for giving you a report of memory leaks when you exit. But while it's running, that's not so useful, particularly if it does actually clean up at the end. So a really, really cute trick is to hook up a signal handler to do something like this. T-event, so hold on, in oserver.c. T-event, of course, does signal handlers as well. So you can say on SigUser1, call this callback talloc dump, and hand it the O server. Talloc dump basically opens a file and does talloc report full, which basically dumps that whole tree for you. And if you want, there's a cute utility, I think, out there somewhere which can convert that to a dot file, so you can graph it in GraphViz and put it on your wall. But you could run that every hour and see, why is this growing over time? And it will show you all your memory allocations and how they're related, and incredibly useful. One of the problems with this implementation, of course, is that your server stops while you're doing this potentially large dump, particularly if you do have a memory leak and it's writing out megabytes and megabytes. So one clever trick is actually do the whole thing in a child, and so the main server can go off and do stuff using the operating system's copy on write for all that stuff. So that's kind of cute. Okay, so that's kind of useful. I'm not going to demo it. Does anyone remember something Tridge wrote in like 98, I think, called genparser.pl? Yeah, Tridge remembers. It's basically a code generator that looks through your headers and generates bundle and unbundle functions for your C code. It is a Perl monstrosity, and so I spent a day converting it to CCAN. I planned to add all these features. I just got it to work, and then I was happy and backed away. But what we can do is if we pull out the types that we're interested in into a separate header rather than leaving them internal, we then include CDump and we annotate them slightly to say which ones we're interested in saving. Any structures that it doesn't see the definitions for, we can either write our own bundle unbundle functions, expose that implementation so it can actually bundle and unbundle them itself, or just say CDump ignore on stuff. So we do that in a couple of places where we can't, where we're just too lazy. It doesn't really matter that we're not dumping that. It's not particularly informative for us. Okay, and now, what's next? So I did have a cheat sheet, but I left it in my bag. Okay, now we have a tool that actually, a little helper file that calls the C code to parse it and everything else. And the first time I ran this, of course, it chewed up all my memory and then fell over. CDump's kind of dumb in the same way that GenParser was, and that is the it doesn't handle loops. So we had a pointer from the O server to the client and a pointer from the client to the O server, and it just went around and around and around. Well, that's kind of easy to solve. We just set the O server, because we know that, to CDump ignore. No point in having the back pointers. But for the sub-client Oracle pointers between the clients, that gets a bit harder. I really should hack it so that it remembers and does ref get. Or I could just change them to integers and use a index. That works too. So that was an easy fix. So we did that. And then, of course, we hook it up to a signal handler and call it dump. There's talloc dump. Here's our dump. We call CDump bundle. We open up a dump file. We write the whole thing out, and then we close it and free the string. So we add CHUP. Basically, we've added a dump file parameter to the O server, server.h. We add a dump file. If they set it to non-null, then we initialize the signal handler to dump out to the dump file. Straightforward. Now, that's probably worth showing, so I'm going to do, let's see if this works this time. Cool. Okay, so it's actually now running our server. We telnet to 28, localize 2828. We're going to that's an interesting question. Okay, and then we kill all dash hup O server. Oh, sorry, it's called example dash underscore info dash O server. And we cat, who wrote this crap? Var run O server dump. And we actually see, there we've actually dumped out the state in a nice readable form. So in fact, you can edit it if you wanted to. Now that's kind of cute. You actually get more visibility into what your server's doing more than just out of the straight talloc dump. But the fun bit is really not dump, it's more restore. CDump can also rebundle it back into your structure. So let's do that. F9, we apply that patch. Now we have an O server restore. So you basically hand it a dump file in event context, and it returns a successfully reconstructed O server, sucks in the file and calls CDump restore on it. Hopefully things work, gets it out. Well, that's reasonably straightforward. Restore, here we go. We wrap all the stuff that we need in both branches into a separate function. So we can just O server restore. We load in the file. If it works, we complete the server. Okay, that's. Remember that stuff we ignored? We kind of need to put it back at this point. So we basically iterate through and we reconnect those O servers and recreate the file descriptor events. So basically re-register everything with the event context, and that works. But the other thing is that CDump doesn't understand talloc at all. So instead of this nice talloc hierarchy, we end up with this flat row of crap. So our talloc hierarchy is simple. So rather than fix CDump, I just talloc steal things back where they're supposed to be and rearrange my tree. All done. Okay, so that gives us a nice restore, but that is completely useless because how do you restore all the connections and everything else? I mean, there's no point other than the cuteness. And this is where you get to the joy of exec. Right, everyone see where we're going now? Okay, so O7H. If they hand in an array of arguments, it means when I get sig_hup, I want you to do this, dump it out, and then exec those arguments. Now, those arguments are the same ones we had before with -- restore put in the middle. When we hit -- restore, we actually try to restore from the file. Okay, now this is my first risky demo. Other than the other ones, this is my first really risky demo. Okay, so we run up the server, I can build it and everything else. Still getting 11 out of 11, that's good. We tell that in and go, this is my question. We kill all. Tell that in again. Another question. Whoa! Okay, it's still alive. That's a good sign. Var run server dump. Indeed, it actually restored the whole question. Wow, that's actually really good. Oh, wow. Okay, so that worked. Good. The real thing means that you can do live upgrades. If you need to fix a bug or whatever, you can basically just invoke this code and re-upgrade. The cute thing is that cdump, when it reads from this dump file, if there's something that is not in the dump file, it sets it all to 0. So this means that you can actually do extensions as well. You can add a new flag or a new pointer in there, knowing that it'll come null when it comes off out of a dump file. So you can either fix it up or just have your code naturally handle that case as null. That means you can do incremental enhancements. Tridge wrote this so that he could do it with his chess server. Without ever taking it down, he could actually upgrade it. Now you can do slightly more complicated upgrades, and you should also probably not do it that way. You should probably do it inside a child. Test that the dump works, because that has a tendency to segfault, and get the infinite loops. And if it works, then have a -- restore - check and try execing that first. If that works, then second time do it for real. But I had perfect faith that this would work. It didn't bother. So, okay, let's leave our successful victim running. We'll move temp secondlint example to user local bin oserver and run oserver -- port 2829. Okay, so the idea was that you guys would be able to go telling in and everything. Yeah, no, we're in trouble. 1 minute warning. Okay, now the other thing that we hit, of course, is this clients array. Brackets 5. Okay, so what we'd really like to do is change that, introduce like a max clients rather than that. The problem is that if we went from here to here and we did a dump, max clients wouldn't be in the dump, so it would come out as 0 at the other end. Several ways of doing that. One is to write the new one to go, oh, 0, you could never be 0, we'll assume that you're 5 or whatever. The better way to do it is to do it indirectly. You do an upgrade like this. You put in max clients, you set it to the maximum number of clients, but you don't actually use it yet. You run that. So you upgrade, that's what I called. This will build it, move it over, and tell the thing to re-exec. So hopefully that has got us to this middle stage here, and then we actually start using it. We actually tell cdump that's the length of the array using that annotation. So now we've actually got a variable number of clients, and then we upgrade again. Still running. Now you were supposed to all be furiously typing away, and suddenly more than 5 of you could get on the server at this point. It was going to be so cool. Okay. Of course, what if you don't have cdump? What about that old Parrot program that we have, for example? What if that were a mission-critical piece of software that you need to upgrade? Well, that's infeasible. I mean, to do it, you'd have to do something like, you'd have to write some kind of script in your favorite scripting language, and it would have to, fire off GDB and attach to it. I mean, when you think about it, though, we didn't, in that original example, you may not remember, we didn't actually save the O server pointer. So you'd actually have to grovel through the event structures to find the one with the right callback and know that the private pointer was our O server pointer. Suck that out, dump it out, grab the file descriptor, walk the whole client array, and repopulate that, parsing the states with some kind of really, really hacky regular expression parser, and then bundle the whole thing up. Tell GDB, please exec the new version with -- restore, and hope the whole thing worked. Now, I would not recommend anybody ever do this. I was at 277. Oh yeah. You'd have to regen that too. Okay. And okay. Wow, my parrot has turned into an oracle. Okay. And we have no time for questions. Thank you.
Well, he's done it again, hasn't he? He's bloody magnificent. When he worked in the large room, you know, the large auditorium that holds about 400 people, we gave him this huge, great bowl of made from macadamia nut shell. Here he's only working in a little tiny auditorium with half the number of people, so we've given him a little tiny bowl.